Welcome back to my UWB project. This is Eric. I'm on the parking structure right now. Since I couldn't properly test indoors, I came out. I initially tested in the park, but the screen is barely visible, so I chose this parking lot. Please don't worry, the test results are the same for both. What I want is how far I can go with one tech device and one anchor device. Although many applications can be created with close-range communication using DW1000, I think it's also important to first know the maximum range that two devices can communicate with. I'm running the system using the Arduino DW1000 library. There are 6 modes we can use. The operation mode is determined by the combination of data rate, pulse frequency, and preamble length. To sum up, what showed the longest cover in my environment is the data rate of 110 kilobits per second, the pulse frequency of 60 MHz, and the preamble length of 2048. These are graphs showing receiver sensitivity for 6 modes. The x-axis shows the RX power and the y-axis shows the received rate. As you go left on the x-axis, the RX power decreases, so it means the distance increases. The top 3 graphs have a data rate of 60 MHz and the bottom 3 graphs are 64 MHz. The 2 graphs on the most right show the better received rate even when the RX power is the lowest. I didn't set the channel, but here it shows that the setting with channel 5, 110 kilobits per second data rate, 16 or 64 MHz for the frequency, and 2048 preamble length can receive even from the furthest distance. Already I'm more than 20 meters away from the anchor. One thing I'd like to mention is what is outputting to the display is the recalculated distance by my code. Looking at the previous video, it was found there was a large error in the close distance test, and this was reflected and recalculated to be close to the actual distance. If it doesn't have the part I made, approximately 60 meters will be displayed on the screen now. Where I'm testing, it seems to be able to receive signals up to about 24 meters. If data is transferred in this distance, I wonder what the result will be. It would be nice to test it out when I get a chance. The datasheet of the DW1000 covers a lot of information. If you do a project with this, I definitely recommend you review it. Also, it's referring to the antenna as well. Depending on the position of the antenna, the signal strength may change. It seems that you can get much better antenna strength when the DW1000 is standing up rather than lying down. Okay, it's time to go back to the anchor device. As you can see on the screen, the distance measured by my device is about 24 meters. I'm wondering how far away it is. While going back, also I recorded the screen of the AR measuring with my iPhone. This is not very accurate, just so we can get the approximate length from end to end. I reckon we can make interesting applications with the ESP32 and UWB. It's possible the indoor positioning with multiple anchors, and outdoors it's possible to notify something like a warning to the other party based on the distance, maybe. Yeah, I need to buy a few more UWB modules. Okay, we are almost here. It's a rough measurement, but I hope the AR measure also shows close to 24 meters. Since accurate distance measurement is impossible with UWB anyway, the error must be fully considered. As a result, about 28 meters were measured. It wasn't a perfect distance measurement, but it's acceptable even considering the error from the AR tool. I'm so happy UWB alone can cover this range. The purpose of the use is different, but if you need long distance communication, it'll be better to use LoRa module instead of UWB. I hope the fun ESP32 project with the UWB will be done soon. Thanks for watching, see you on the next project.